Chapter 1, Research Methods in Psychology. So today we're going to talk about some of the basic ways that psychologists conduct research. Okay, so we have already established that psychology is a scientific discipline. We use the scientific method to answer our research questions. So the first step in the scientific method is to come up with some kind of testable question. What are you interested in studying? So let's say that you are interested in studying the effects of divorce on academic achievement. So you might say, how are divorce and academic achievement related to each other? That's your testable question. From there then, you'll develop a hypothesis, your best guess about how you think those two things, divorce and academic achievement, might be related to each other. Your hypothesis is grounded in research that other people have already done. So you'll be looking at studies that have already been conducted to come up with your best guess, what you think is most likely to happen. So let's say that you believe that if people experience divorce, they are likely to show lower levels of academic achievement compared to people who do not experience divorce, who do not come from families that have experienced divorce. So that is developing a hypothesis, again, based on previous research. So then you want to test that hypothesis, right? You have to design some kind of a study. There are two options that you have. You can design an experimental study, which we'll get into later on in this presentation, or you could design a descriptive study to test your hypothesis, and we'll talk about those later on as well. After you have collected your data, after you have run your study, you want to analyze your data. What did you find? What are the conclusions that you can draw? Bringing together multiple different sources of information, what do they say? And then, based on your conclusions, you need to report those findings. So it doesn't do any good if you conduct an amazing study and no one ever hears about it. That doesn't help us to advance science. So your job then is to report those findings through some kind of avenue. So you might choose to report your findings in a professional or scholarly journal. You might present your findings at a conference or something of that nature. So let's talk about research strategies. There are two ways that you could design your study. You could adopt a descriptive approach. With descriptive research, you are only observing or describing behavior. You're telling us what's going on, okay? You're not establishing cause and effect. You're just observing, describing what is happening. With experimental research, though, you can actually establish that one thing causes the other. That changes in, let's say, exposure to a certain amount of medication cause lessening of depressive symptoms, okay? And we'll talk later about how experiments allow you to establish cause and effect, whereas descriptive studies only allow you to observe or describe behavior. Descriptive methods, then. Just describing behavior. There are several different examples that we'll talk about here. We'll talk about case studies, observational studies, and surveys, all as examples of descriptive research methods. So first, case studies. So with a case study, you are providing a very, very detailed description of either an individual person or of a very small group of people. Oftentimes, case studies are used in psychology when we are trying to describe something that's atypical, something that is abnormal, that is statistically very rare, that doesn't happen often. So, for example, dissociative identity disorder. It used to be called multiple personality disorder, and when this was first becoming recognized in the 60s and 70s as a real psychological disorder, there weren't a lot of cases, right? Statistically speaking, dissociative identity disorder or multiple personality disorder is very rare in the general population. And clinicians began to write case studies, very detailed accounts of clients that they were working with who had this particular condition. One of the problems with using the case study approach is that we're only focusing on one person or a very small group of people. One of the goals in doing research is to be able to take the results that we get from a sample or a subset of people and be able to apply it to the entire population. That's called generalizing, taking the results that you get from a subset or a group of people and applying them to understanding a larger group of people. However, if we only have one person who participated in our study, one case study, it's going to be really difficult to say that the experience of this one person applies to understanding the experience of many people. It doesn't necessarily generalize. So that's a weakness in using case study. Observational studies are another kind of descriptive study. And with observational studies, we observe and record behavior, but we're not interfering with the behavior. There are two ways that you can conduct observational studies, and each has its pros and cons. So with naturalistic observation, you observe someone or something, animals, right, in their natural environment. So this means, let's say you're interested in studying parenting behaviors. You want to do this from a naturalistic observation perspective. So you go to the mall this weekend and you watch pairs of parents and children, okay? Naturalistic observation. The good thing about naturalistic observation is that you're more likely to get an accurate representation of what people really do, what people typically do, because they don't know that they're being observed. So they're more likely to show you their normal or typical behavior. You could also adopt a laboratory observation as one of your descriptive research methods. Laboratory observation, you would essentially invite someone in to your laboratory, to some kind of controlled setting, and observe their behavior in that setting. So let's say, again, you're interested in studying parenting behaviors. You could invite groups of parents and children into your laboratory and then give them some kind of task to do, say putting together a puzzle. And while they're doing this task, you are going to sit there and observe their behavior, observe how they interact with one another. The good thing about laboratory observation is that you get to control essentially what your research participants experience during the study. You don't have to worry about, other people coming in. You don't have to worry about outside things kind of contaminating your observation of them. The downside of laboratory observation is that people know they're being watched, right? They know that they're being studied. And when you know you're being studied, sometimes you change your behavior. Think about, if you have ever had a job and your boss is standing right there at your job watching you. You probably do a pretty good job, right? When you're there, you probably follow all of the rules. You're on your best behavior. When your boss isn't there, maybe you slack off a little bit more. But the point is that your behavior changes when you know that someone is observing you. You could also choose to conduct surveys. Surveys are great tools to basically reach a lot of people, right, in a short amount of time. You can administer many questionnaires all at the same time. You can interview people as well if you want to kind of supplement the information that you learn in the questionnaires. In conducting surveys, it's very important to make sure that you have a representative sample. So you want to make sure that the people that are participating in your survey are similar to the general population on important characteristics like age and sex. So remember, we said before that one of the goals of research is to be able to take the findings that you get from a small group of people, we call that a sample, a small group of people or a sample, and apply those results to understanding a larger group of people or a population. Okay, so let's say that you are interested in studying how first semester students adjust to college life. Okay, you're interested in studying how all of the first semester university students in the United States are adjusting to college life. So your population is university students first semester in the United States. That's your big group. To study that, you would survey a sample from that population. So you would get some students who are first semester students, university students. If you only had people in your sample who were female, who were 18 years old, who spoke English as a second language, and who were Southern Baptist in their religious orientation, you wouldn't be able to take the results, right, from your survey and apply them to understanding the entire population of first semester students in the United States. You would need to make sure that your sample, the people who participate in your survey, are representative, that they more broadly match what the entire population looks like, not just a very, very unique portion of the entire population. Additionally, in conducting surveys, in conducting research in general, there is this phenomenon called volunteer bias. So volunteer bias essentially means that people who volunteer to participate in research may be different from people who do not volunteer to participate in research. So they might have some characteristics that make them very different, and this might impact how much you can generalize, right, the results from your survey to understanding the larger population. So for example, people who volunteer to participate might feel very strongly about a particular issue. If someone comes up to you and says, I'd like you to participate in a survey about violence in American schools, and you have a lot of strong opinions on that, you might be more inclined to participate. If, however, you couldn't care less, you might not participate at all. Additionally, people who volunteer to participate in research might be more extroverted, they might be more outgoing than people who do not volunteer. So we have to keep those things in mind as well in conducting research. Okay, so that takes us away from our descriptive methods and takes us into research design, right? So now we're going to talk about variables. Variables are anything that varies, anything that can be measured, rated, or scored. So variables essentially are the things that you are interested in studying in your research. These are what are contained in your research question. So at the beginning, I talked about a hypothetical study where we look at the experience of divorce and how that may or may not be related to academic achievement. So in that example, our variables are divorce. Have you been in a family where you experienced that or not? That's a variable, right? Different people will have different responses to that. It varies from person to person. Academic achievement. We can measure that in a number of different ways. We might be interested in your grade point average. That's something that we can measure, right? And something that will vary from person to person. We might look at your SAT or ACT scores. Something that we can measure, something that will vary from person to person. So variables essentially are the things that you are interested in studying Other examples include things like height, weight, IQ scores. All of these things can be measured. All of these things are different from person to person. When we're conducting scientific research, we manipulate these different variables. That means we expose people to different degrees of these variables. We'll talk about that more when we get into experimental methods. And we assess them. We measure them in scientific studies. Okay, so another design that you might choose in conducting research is a correlation design or correlational study. Correlational methods, by definition, are descriptive. We are simply describing the presence or absence of a relationship between two variables. So if you look at the word correlation, you see that it's made up of two different parts here. So we see co right here, meaning together, right? So two variables together. Relation, they relate to each other. So two variables relate to each other. How do they relate to each other? The correlation or correlational study describes that relationship between these two variables. So correlational studies then produce a statistic called the correlation coefficient. And remember, a coefficient is simply a number. In this case, the correlation coefficient tells you how strong the relationship is between two variables, and it also tells you the direction of the relationship between the two variables. First, let's talk about the strength of the relationship. So correlations can range from -1 to +1, okay? They'll never be more than 1. This coefficient tells you, this number tells you how strong the relationship is between the two variables. So in looking at correlation, it's important to just look at the absolute value of the correlation coefficient. Don't pay attention to the sign for right now. So the closer this coefficient is to 1, whether it's +1 or -1, the stronger the relationship is between the two variables. The closer the coefficient is to 0, the weaker the relationship is between the two variables. So then which of these is stronger? A correlation of -0.89 or +0.43. Remember that we're looking at the absolute value of the correlation coefficients, and the sign does not matter in telling us about the strength of the coefficient. So if you picked -0.89, you are correct, right? That is closer to 1 than 0.43 is. Good. Okay, so the direction of the correlation, that is given to us by the sign that is in front of the correlation coefficient. So if there is a plus sign or a positive sign in front of the correlation coefficient, that tells us that we have a positive correlation. That means that these variables are positively related to each other. A positive correlation means that the variables move together. They either increase together or they decrease together, okay? They always move in the same direction. They either increase together or decrease together. So that's a positive correlation. So going back to our example about the experience of divorce and academic achievement, if we found that those two variables are positively related, we would say that as the experience of divorce increases, meaning have you experienced divorce or not, as that increases, academic achievement also increases. That would be a positive correlation between those two variables. another positive correlation, we could say alternatively that as the experience of divorce decreases, academic achievement also decreases. They are both moving in the same direction. That's a positive correlation. We can talk about negative correlations as well. And with negative correlation, the variables move in opposite directions. So one variable increases and the other variable decreases. Okay? So they move in opposite directions. One goes up, the other goes down. Okay? That's a negative correlation. So taking our example again about divorce and academic achievement, we could say that if those were negatively correlated, we could say as the experience of divorce increases, academic achievement decreases. Or as academic achievement increases, the experience of divorce decreases. That's a negative correlation. They move in opposite directions. Okay, so let's try some examples here to help you understand this more. So which of these is correct? A study of married couples showed that the longer they had been married, the more similar their opinions on social and political issues were. Okay, so it sounds like we have length of marriage. As length of marriage increases, similarity in opinions also increases. So these two things are moving together. They're moving in the same direction. So if you picked positive correlation for this one, great job, you're correct. These variables are moving in the same direction. How about this one? A college professor found that the more class absences students have, the lower their grades in the course tend to be. Okay, so more class absences, so that's increasing, right? That's going up. Lower grades in the course, so the grade is decreasing, so they're moving in opposite directions. Absences increase, the grade decreases. Moving in opposite directions, so if you picked negative correlation for that one, great work. Those two variables are negatively related to one another, negatively correlated. Okay, so with correlation, one of the difficulties in using correlation is that we're just describing a relationship. We can't establish cause and effect. And we can't establish cause and effect because we can't determine what you are going to be exposed to. We can't really manipulate variables. You guys have heard of a control condition, a condition where people participate in a study but they're not exposed to anything in the study. Let's say we're interested in testing out a new antidepressant drug and we want to know, does this drug work? Does it lessen depressive symptoms? So we might have a control condition where we have people, we don't give them any medication at all, and then we observe the effect of that on their depressive symptoms. Then we give people our drug, whatever we're interested in testing, and then we observe the effect of the drug on depressive symptoms. If we see a difference between those groups, between the control condition and the people who received the drug, we can say it must have been receiving the drug that caused the change in depressive symptoms. We have manipulated that variable. We have manipulated the experience that you had. We have caused it and observed the resultant effect. With correlation, though, you don't get to do that. You don't get to manipulate different variables. We're just describing a relationship. So let's say you have a study here. You're interested in understanding how television watching and hyperactive behavior are related to one another. So we want to know, does television watching cause hyperactivity? these two things are correlated, but does one cause the other? Possibly, right? But we always have to entertain other possibilities, other alternatives when we're using correlation. So it might be that television watching causes hyperactivity, where kids who watch more television are more likely to show hyperactive behavior. That's one possibility. It might be, though, that hyperactivity causes television watching. What if children who have a predisposition to show hyperactive behavior are more drawn to watching hours and hours of television programming? They like TV because it's constantly changing, right? It's something that kind of holds their attention, that stimulates them. It might be, though, also that the relationship, the correlation that we have observed between our two variables, television watching, hyperactivity, it might be that that relationship is caused by something completely different, what we call a third variable problem. They might be caused by this variable of Z. They might be caused by something that we're not even aware of. So what if the relationship between television watching and hyperactivity might be explained by variables in the home? So, for example, maybe parents who allow their children to watch a lot of television have attention problems themselves, and therefore they create a home environment that fosters hyperactivity and inattention. So whenever you are talking about variables being correlated, it just means that they are related to one another, but correlation does not allow us to establish cause and effect. So you're probably thinking then, why would you ever use correlation if you can't definitively establish cause and effect between variables? Well, correlation is often used in the social sciences when it would be difficult or unethical to assign someone to a particular experience or particular condition. So in our example previously, where we're investigating the effects of drugs, of antidepressant drugs on depression, we can assign people, right, to be exposed to different amounts of that medication. There are ways to do that and have the study be completely ethical. However, there are some variables that we might be interested in studying, some research questions where it wouldn't be ethical to expose people to certain things. So for example, if I am interested in how men experience anxiety, I can only have my study open to men, right? I couldn't take women and say, okay, so for the purposes of this study, you're going to be a man. That's the condition that I've assigned you to. You are a man. You can't do that, right, with gender. What if you're interested in studying the experience of child abuse? You can't take, one group of children and say, okay, this year you guys are going to experience horrific child abuse. And then take another group of children and say, okay, this year you will not experience any child abuse. And then we're going to observe the effects, the differences between these two groups of kids. You can't do that. So sometimes correlation is the best that we can do. Okay, now moving on to another way to design research studies, the true experiment. So the experiment is considered the gold standard, a controlled test of a hypothesis where the researcher manipulates or changes one variable to see the effect on another. Okay? So instead of, with our descriptive studies, instead of passively observing and describing behavior, the researcher actively does something that the researcher believes will affect behavior, and then they observe what happens. So because we are actively manipulating the situation and then observing the resulting behavior, an experiment allows us to draw cause and effect conclusions. It's the manipulation, the change in exposure to one of the variables that causes the change in the behavior, the resultant effect. So experiments then include several different things. We have our variables of interest. What are we interested in studying? What are we looking at? We also have our control conditions, the condition where people receive none of the variable of interest. They're not exposed to that, so that we can observe the effects compared to people who did receive whatever the variable is that we're interested in studying. Experiments also include random assignment. So in an experiment, we have different conditions, right? We have a control condition. We have conditions where people are exposed to the variables that we're interested in studying. And as researchers, you need to make sure that you randomly assign, randomly determine, will this individual be part of the control condition or part of the experimental condition? And this helps to control for some of those problems that we talked about earlier, things like volunteer bias or coming up with a representative sample. It helps to kind of balance out the characteristics between your different conditions. And an experiment, very, very important. It can show cause and effect. It can establish cause and effect. Okay, so with your variables of interest in your experiment, what are you interested in studying? We have two kinds of variables. First, you have your independent variable. Your independent variable is whatever you are manipulating or changing. It is what causes the effect in your outcome, in your dependent variable. Your dependent variables then are affected by the independent variable. Your dependent variable depends on exposure to the independent variable. The dependent variable is your outcome. It is what is measured. Okay, so let's take an example here. So let's say that you want to experimentally study how the number of hours that you work each week is related to student grade point average. So you want to study that using an experiment. So our independent variable then, whatever we are manipulating or changing, that's the number of hours that you work each week. And then what are we measuring? What's our dependent variable? That is grade point average, right? So independent variable, number of hours that you work, grade point average, dependent variable. So this is one potential way that we could design an experiment to determine, does the number of hours that you work each week cause grade point average? How could we experimentally test that condition? So this is a very simple experiment. But so in one condition here, we have you work 0 hours per week, right? This is the control condition. And then we observe the effect on your grade point average at the end of the semester. We have another condition. Some people will only work 5 hours per week at their outside job, and then we will observe the effect on their grade point average. Some people, however, will work 10 hours per week, and then we will observe the effect on their grade point average at the end of the semester. It's important to note that in an experiment, everything is the same across each condition except your exposure to the independent variable. So everything else is held constant. Everything else is the same. And we do that so that at the end of the study, you can't say something like, well, probably, the reason that you got the results that you did, you only had students who were business majors working 0 hours per week, and you only had psychology majors working 5 hours per week, and you only had English majors working 10 hours per week. So maybe the effect that you've observed is not due to work, but it's due to college major. So you need to be very careful that you try to keep everything else constant across the three conditions to be able to rule out those mitigating possibilities later on when you're looking at your results. Okay, So an experimental study. An experimenter wants to study the effects of music on studying. She has some students study while listening to music and others study in silence and then compares their test scores. What is the independent variable in this experiment? So what are we changing? What are we manipulating? So what are we changing? What are we manipulating? What are some people exposed to and some people not exposed to? So if you picked the presence of music while studying as the independent variable, great job. That is what is being experimentally manipulated in this particular study. Some people are listening to music, some people are not, and then we're looking at test scores. Okay, same scenario. This time though, we're looking for the dependent variable. What is the outcome? What are we measuring? So we've already established that we have manipulated the presence of music while studying. That's our independent variable. And we're observing the effect of music on test scores, right? So if you picked test scores as the dependent variable, great job.